Assalamu alaikum, my dear students of class 9 and 10. I am A.K.M. Tajuddin, Assistant Professor of Physics in Physics Department of Rajputra Model College. I think you are passing very boring time. That's why I want to pass some time to enjoy physics with you. And since you are missing so many classes in the Raju College, so we could not finish our syllabus properly. That's why it will help you. The class I am going to take with you, it will help you to complete your syllabus, as well as you will learn so many things. Not only that, if you feel you want to solve some problems, then you can write to me to this email address taz73 underscore uddin@yahoo.com, or you can write text to me 01727103811. Okay, and what I'll do, I'll try to complete your syllabus, and what chapter I'm going to discuss. Let us start it. First of all, I'll show you some video clip, then you will understand which chapter we are going to start. Okay, pause. Pause. Okay, start.
Things go forces make things go down. Forces make things go back and forth. Forces make things go round and round. Forces push, push, push. Forces pull, pull, pull. Here are some things that forces make move. When you slide your chair back in place, a push is the force that makes it move. When you jump up high in the air, a push is the force that makes you move. When you come back down from a jump, a pull from gravity makes you move. Forces make things go up. Forces make things go down. Forces make things go back and forth. Forces make things go round and round. When you tug the rope in a tug of war, a pull is the force that makes it move. When you bend down and pick up a book, a pull is the force that makes it move. When you fly a kite in the air, a push from the wind makes it move. Forces push, push, push. Forces pull, pull, pull. Forces make things move. Forces are all around.
Stop.
If you
Okay, my dear students, I think from the video clip now it is very clear to you what we are going to discuss. The topic we are going to discuss, it is chapter 3. You know what is in chapter 3? Force. So the thing you got from the video clip, any kind of push or pull or attraction or repulsion or any kind of movement that needs a special thing, that is called force. So force is need everywhere, but force, to discuss about force we need some other matters related with force, and these two matters are mass and inertia. Force is related with mass and inertia. Now we have to know mass. What is mass and inertia? Mass is the matter of Mass is the amount of substance or amount of matter. Amount of matter. And inertia is the property of matter. Property of matter which wants to keep a body at its own state of motion. State of motion. It means if a body at rest, then it wants to remain at rest, and if a body in motion, it wants to remain at motion. So inertia is very much related with the mass, and inertia is very much related with the force. If mass is more, then inertia will be more. If mass is less, then inertia is less, because we need more force. It means there is the more inertia of a truck than a bicycle. So we have to push very small to a bicycle to make its movement, but we can't move a truck even we apply a very strong force. That's why inertia is the property of the matter to remain at rest or in motion, uniform motion. Let us discuss some examples of inertia and mass. Okay, let us see a video clip again.
Okay, for mass, mass is the matters you have in an object.
So mass is the amount of matter, and
for mass, mass is the amount of matter, how much matters you have in an object, and the SI unit is kilogram, and it's a scalar quantity. It has no directions, so that's the first things that you need to know. The second thing is the concept of inertia. So what is inertia? Now, inertia is the properties of a body that tends to maintain its state of motions. This is definitions. I'm going to explain to you later. Okay, but you need to memorize these definitions because in exam they may ask you to give these definitions. So it is the properties of a body that tends to maintain its state of motions. What does this mean? What does this mean? It means this example. So we have a coin. Okay, we have a coin, and as the coin lies on this cardboard. Okay, and then we have a glass here. Now, if the card is jerked quickly, so you pull the card quickly, you will find that the coin will not move together with the card. It will not move together with the card, but instead it will drop into the glass. Okay, it will drop into the glass. So why? If you pull it slowly, this coin will move together with the card. But if you jerk the card, then the coin will not move together with the card, but it will fall down into the glass. Why? That is due to inertia, because inertia is the nature of all mass. Okay, that resists the change of the motions. It don't want to change the state of motions. So coin resists changing its state of motion, which is stationary, due to inertia. Okay, and as a result, the coin does not move together with the card but falls into the glass due to gravity. Let's say you pull a book very fast. You pull the book, okay, then you will find that the book above it, okay, will not move together with this book, but it will fall down and then lie on this book below. Okay, this is also because of inertia. Okay, yeah. So the book fall directly downwards. Of course, you need to do it very fast. Okay, must do it very fast. So this is because the book on top oppose the change of their stationary situations owing to the effects of inertia. Okay, when a book is pulled out, the book on top not follow.
Okay, my dear students, I think you get some ideas about inertia, mass and force that you go through when you go through the video clip. and I want to discuss with you about the examples of inertia. You saw when a coin kept on the cardboard on a glass, then if the cardboard is moved or jerked first, then the coin go inside the glass due to inertia. And again another one is there are so many books. If you push or pull a book from anyone from the middle of the books, then the upper books goes down. It is also due to the inertia. So inertia is the property of matter to remain at its own state of motion, to remain in motion, or if a body at rest it wants to remain at rest. That property is known as inertia. Okay, pause. So what is our lesson today? The lesson is related with mass, inertia and force. So you think I think you get the points in conclusion. What is mass? What is inertia? Mass is the quantity of matter in a body and its unit is kg. Again, inertia is the property of matter to remain in its own state of motion or rest. Mass of body measures inertia of a body. So if mass is more, then inertia will be more, and vice versa. Inertia are again two types: inertia of rest and inertia of motion. Let us discuss some examples of inertia of rest and inertia of motion later. And what about force? Force is that which changes or tends to change the state of matter of a body at rest or in motion. So all kinds of push or pull or attraction or repulsion, collision, interaction, all are the examples of force. Okay, so pause. Okay, so inertia are again two types: inertia of rest and inertia of motion. Inertia of rest and inertia of motion. If I discuss some examples, then you will understand it very clearly. Inertia of rest means a body wants to remain at rest until any force is applied on it. And inertia of motion, it means a body always wants to remain in continuous uniform motion until any force is applied on it. And we very frequently we see the examples of this kind of inertia. For first, inertia of rest. For example, when we are standing in a bus and suddenly when the bus starts to move, then the passenger moves backward because of inertia of rest, because the lower part of the passenger is connected with the bus. So when the bus starts to move, then the upper part of the body wants to remain at rest and it goes backward, it goes backward. And again, for inertia of motion, when a running bus suddenly applies the brake, then the lower part of our body wants to come at rest, but the upper part wants to remain in motion. That's why we leans forward. So these are the examples of inertia of rest and inertia of motion. And Newton made a relation among inertia and force, which is known as Newton's first law of motion. So so now I write Newton's first law of motion. Newton stated if a body at rest or in motion, then its state of motion or rest will not be changed until any force is applied on it. This is the Newton's first law of motion. So from Newton's first law of motion, we get the idea of inertia and force. Force is that which breaks inertia of a body. So from Newton's first law, it is very clear to us, there is a force is must required to change the state of motion of a body. Okay, so I write it on the board. Pause. Yeah, should we say? Okay, please everybody write it. Newton's first law of motion. Newton stated a body at rest or motion will remain at rest or motion until any force applied on it. So I will show you a video clip to you again so that you can remember it completely.
Newton's first law of motion. In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked on the ground would keep moving forever, or after some time would naturally stop moving? The ball will continue to move unless an object of force stops it. Here comes Newton's first law, which states a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force.